Exactly. Keep sending it, and then we will be posting them and showing to the audience in the next breakout.
Exactly. Okay, so now let's continue. Our next speaker now hitting the stage is Amar Solkar. Amar is a student at Cebu City College of Engineering.
Yeah, and then we know, all of us, we know about the ROS navigation stack, right? Which is the software that allows the robots to move from one point to another in a safe way. And ROS navigation stack, it works quite well, but we have the problem when we are in a big space which is divided into different floors. So how can we manage this kind of navigation? Then Amar is going to show us a solution for this problem in his next speech. Hello, Amar. Are you ready?
Hello, hello, hello.
Perfect.
Hi, everyone. Can you hear me?
Yes, we can hear you
Yeah.
clearly.
Okay. Then the audience is
Hi.
all yours.
Okay, thank you. So, hi, everyone. I am Amar. Thank you for the introduction. So, I'll get started with the background a bit. So, as consumer and service robots become more common, the need for robots to be able to navigate between multiple floors in homes, buildings, offices will become more prominent. So, to do this, we need a way to navigate between multiple floors, and this is what my topic is about. So the key learning takeaways we'll have after this project is we'll learn how to use the map server with multiple maps, save the coordinates for later use, like important coordinates which we need, and navigate between floors using the coordinates that we save and the maps we have. A bit about me. They gave a good introduction that I'm a mechanical engineering student. I'm a graduate. I developed a delivery robot for multi-story buildings. So I'll give you a glimpse of what it looks like. So we drop the robot at a drop point. It navigates through the lobby area to the elevator. It waits for the elevator. Then it goes in the elevator. Then it changes the floor. Then it goes to the room that it has to deliver and then drops the package and then get back to the pickup area where the delivery van or anything can pick it up and take it back to the warehouse. So this is a somewhat what we will be building today. I hope you guys are excited. So I've divided my presentation into 4 parts. The first is getting familiar with the robot environment so that we know what we are working with. Then we'll be building the multi-map server. Then we'll look how to save the coordinates, and then we'll see how to use it all together. So let's get started. To start the simulation, we'll just launch the simulation, the code, run it in a web shell. As you can see, the gazebo and ROS is launched. Okay, we'll unpause the simulation and focus on the robot. So here we have a simple robot which has a door and a pusher to manipulate the package. So I have provided several services which we can call to control the robot on the control the door and the pusher of the robot. So for example, if we call the delivery bot open bot door, it should open the door. So if we set the set pusher out, we call that service, it will set the pusher out. So in this way, we can push the package out of the robot. Similarly, then we have a service called the deliver package, which executes all the services in a flow. So it will open the bot door, it will drop the package, and it will pull the pusher and then close the door. So now that we have seen the robot, we'll then move to the elevator, because the elevator is a very important part of the simulation, because that is how we are changing the flows. So in gazebo, you can actually you have a elevator plugin which you can use, but what I found out during building my project is that it is very limited. So what I did was I created a new elevator CAD model and then made it as a robot. So now, so in this particular simulation, there are two robots: the robot, the delivery bot, and the elevator. So I'll set this to transparent so you can see it. So suppose we call this service called open elevator doors. So we can see that the doors are being opened. So there is a similar service for closing the doors. And then we have a service to which we can use to ask the elevator to change the floor, like go to floor 1, go to floor 2, go to floor 0. So I'll set it to go to floor 1, run it. So it will first close the door and then move to floor 1. So like in this way, we can have the robot move into the elevator. Then we can change the floor of the robot using this. So you can play around with it when like later when you have time, you can play around with it. And now we'll move to the building the multi-map server. So first we'll create a package, a different package we need. So we'll create, we'll first change right to the workspace. And we'll create a package called multi-map server and add all the dependencies which are required. So if you open the IDE and you go to source, you go to RDD21 delivery bot, and then you go to multi-map server, you can see that the package has been created. Now we need to create the service file first. When we call the server, we'll call the service, we'll say to the map server, like I want to load this map, I want to load this map. We have to pass a string the path of the file to the service. So for that, we'll create a new service. We'll go to the, we'll first create a service folder. We call it as RV. Then we'll create a new file. We call it map file path.srv. Once that is done, we'll just copy paste this. So what it is it takes an argument of a string type, that is a map file path, and then it gives back a result which is a boolean type success. Once that is done, we will update a CMake list. Go here. We'll quickly update everything, the CMake list. We'll go to add the service file with that we just created. We'll generate the dependency, generate the messages. And then we'll lastly catkin package. So after this, we are done with the updating the CMake list to add the map file path. So then we'll go to the base of a workspace. We run catkin make. It should generate all the necessary files required to use the service in our actual programs. So we'll wait for it to complete the build process. Then we have to remember to source the thing we just made. Then to test that a service has been created successfully, we'll use ROS service show and then a file name, service name. So as we can see, it returned correctly the file that we use. So we know that a service has been created. Now that we have created a service successfully, we now move on to creating the node, which is the actual node which will allow us to change the maps and provide a map to the robot. So we'll go to again back to the map server package, and then we'll create a new folder called scripts because we are doing it in Python. So it should be made. We'll create a new file. Map server. Node.py. So we have a new file, then we'll copy paste this code. So the problem with the map server package that is already available is once you launch the map server, the map gets latched. That is, you cannot change the map by running it again. So what the workaround is to kill the terminal and then launch the map server again. So that is exactly what we are doing here. We create a node which can do that for us. So we create a service, then we add the callback. What the callback does is, first when we send the map, like open this map for me. So what it does is, so it kills the previous map server which is running and then opens a new map server. So once we are done with this, so we'll update the CMake list again. We added a Python file, so we have to add it in CMake list.txt. Add this, then we'll this. We'll change directly to our scripts. We'll make a new node executable. Then we'll again switch back to our main directory. Then run cat can make. After that is done, we'll source it again. And now we'll test the map server that we just created. So to test the map server, we need to have map server, and we cannot create it right now because it will take a lot of time. So I have already created some maps for us. If you go to delivery bot mapping and go to the maps folder, you can see a folder named building. That is the specific area which we are mapping for. And then you can see two maps, that is floor and lobby. This is what we will be using to test the map. There are also two other files, building.yaml and locations.yaml, which you don't need to worry about. We'll come back to that later. So we'll instead of having to type the whole path of the file, because we need to pass an absolute path, we'll create a global variable which we can use to reduce the typing required. So I'll copy paste this code and add that to bash RC. So then next I'll source the bash RC that we updated, and then echo a global variable. So as you can see now, we have the maps folder and a global variable. Now we already have a gazebo and ROS running, so we don't need to do this again, ROS core, ROS and ROS. We'll just directly go to the next place and launch a new multi-map server node. So a map has started. Then we'll call a service, that is the load map. We created the load map service. Now we call it with the global variable. So as you can see, it launched the lobby map which we require. We'll give it a post estimate. We'll give it a better post estimate. So once this is done, this is pretty standard map server, nothing. But now what we'll do is we'll ask it to load the new map. So I'll call the service again and ask it to load the floor map for us, and we'll see that it has done that. So we don't need to do it manually. We have a server which can do it for us. So again, now the robot is out of the map, so I'll just ask it to load the lobby map again. So we have done that. So now we have successfully tested our map server. Then we move to part 3, which is saving the coordinates. So the reason why we need to save our coordinates is to so that we can use it later to automate the process. Like right now, we can manually ask the robot to go, okay, go here, then wait for it, and then go inside the elevator, then wait. But if we have the coordinates already saved, we can then create a node which can do it all together for us. So that is why we first save the coordinates required. So what we'll be doing here is creating a graphical user interface for marking location. It is a very simple one. All it does is take a name and has a button which you can press so that the location, the X, Y, and orientation of the robot will be marked. So we'll again open the IDE. We close this. Go to scripts. We'll create a new file. This location marker.py. And that will copy paste this code. You don't need to worry about this code a lot because most of it is just for creating the graphical user interface. The only thing you need to give more attention to is this function, that is the mark location. What we do is we use the TF to ROS and TF conversion to get a lookup transform between the map and the base link of the robot. And then using that, we find the X, Y, and A angle orientation and then save it to a file. So we'll update our CMake list again. Now we just update this, save it. Then we have to build it, make it executable. So ROS CD to the scripts folder. Then we'll make it executable. And now we'll have to test it. So to test it, what we'll do is we'll create a blank file called locations test.yaml. In that we'll create a empty collection and save it. So when we run our graphical user interface, we have to give it the path to a file where it will store everything for us. So we just created the file. Now it has a simulation. We don't need to do that. We have to run the location marker. So we'll cd we run this. You can see. Okay, this interface is up. So now suppose I want to call it a drop location. I'll type in drop location and click mark. So if you see in the just a minute. Launch it again. I think I made some typo somewhere. Just okay. No. It was just wasn't updating it. So we can see that it marked to two locations: the drop location which we marked first time, and then the lobby. So now we'll ask the robot to move somewhere. Then we'll go back to our user interface location. To market. So we can see it here. So in this way, we can mark the important locations which we think we'll need during the navigation process. Now we have a service which can do that for us. Now that we have done the first two parts, we'll close everything off. Stop the keeper once. Kill all Jesus server. Once more. Now what we'll do is we'll do the same thing. We'll launch the simulation first. Building world.launch. We'll unpause the simulation. We'll move to our robot. Move to, and we'll set to follow it. And we'll set the view to transparent so we can see what's inside it. So I have a simple node which spawns a package inside the robot. So we'll run it quickly, and you should see a small box inside the robot. So we'll treat that as a package which we have to deliver. Next, we'll ensure that our map folder path is still there. We'll do an echo. It is there, so no problem. Clear. Then we'll run a multi-map server node to provide the maps to our robot. Now it is running, and we'll call a first map, which is the lobby map. It should be there. So now we can see that the map is loaded correctly, and now we can give the post estimate to our robot. A little bit more to the right. Yeah, looks good enough. So now what we can do is I have actually created a locations for this particular map beforehand, so that we don't have to spend more time in moving the robot around and saving all the locations. So if you go to the Catkin workspace, source, delivery bot mapping, maps, building, and then locations.yaml. So here I have several locations marked, which is the drop location where that is the initial position of the robot. The pickup location, it is same as the drop location, just in the inverse orientation. Then we have the locations for the room 1, room 2, room 3, room 4. And then two locations, which is the wait elevator, which is where the robot has to stop to while waiting for the elevator, and wait floor, that is the point inside the elevator where the robot should wait, like the floor to arrive at the floor, then wait till the door opens. So now what we'll do is we'll use this location and manually send the goals to our robot. So now we have this running. Side. So to send the locations, I have created a simple send goal node. If you want to see how to do it, and I have provided two references you can see in the 1 and 2. The first is the reference from where I actually got the inspiration on like how to use it, and then second is the actual file which we are using. So I'll take this and give it the location of the wait elevator. So it should start moving. So as you can see, it got the goal to go there and wait for the elevator. So meanwhile, while it reaches it, what we'll do is we'll quickly ask the elevator to open the doors. So I've provided a reference table so that you don't have to remember everything. So there is the service for opening doors. If you see, we can see that the elevators open the doors. We wait for the robot to reach there. So what we can do is to send a goal, we copy paste this, and then we can take the locations. Suppose I wanted to go to the weight floor location. So what I'll do is I'll add this there, the x, y, and a coordinates, and then send it. So if I see in ROS, it should show me the new goal. So now looking up and putting it down will take a lot of time. So I've provided a simple step-by-step for the final run that we are doing right now. So we have done loaded the lobby already. We have loaded, we have sent it to wait for elevator. We have opened the doors. We have asked the robot to get in the elevator. Now what we'll do is close the doors. Ask it to close the doors. Once the door has closed, we'll ask elevator to go to floor 1. So we'll call the ROS service call elevator, elevator go to floor, and floor, that is 1. So we can see that the robot is moving up inside the elevator, and once it has reached the floor that we need it to, we'll ask the elevator to open the doors. So now we are currently on the lobby map. This map would work in this scenario, but suppose if the floor and lobby maps are very different, then this map would not work. So what we'll do is we'll ask the map server to load the floor map for us. So we'll call ROS service call load a map and pass the floor map. So we can see that it has changed the map for us. Then we'll ask the robot to go to door room 2. So we'll send a goal. We can watch it go to the required location. So I've used a different environment for this because the previous one is very big and it will take a lot of time to traverse through it. So I created a small environment to do the test, but you can do it in different scenarios. So we'll wait for it to get into position. You can also see it here from the top down view. So once it has reached the location, we'll ask it to drop the package, and that is to deliver the package. So we'll call ROS service call deliver package. So it will open the door, push the package out, and then close the door. So in this way, we have essentially moved from the lobby of the building where rode the elevator, then get to the floor, get to the room, and drop the package. So suppose I want the robot to go to room number 1, what I can do is I'll go here, all the service, go to this, copy paste the locations for room 1 and send it. It will just turn about and go to the room 1. So in this demo, we have had to give it the commands manually, but what you can do is we can create a node that does that for us. Like if we provided the locations and that it needs to go through and the maps, then we can create a node that does everything for us automatically. It's like suppose it will change the map for us, then it will ask the robot to go to the send the location for the wait elevator, then it will request the elevator to open the door for it, then it will get in the elevator, then again change the floor, then ask the elevator to again open the doors, then move out, then drop the package. It can do it automatically. So once we have the manual way of doing it, we can then automate the process. So now once it has delivered the package, we can again do the inverse steps, ask it to go back in the elevator, go a floor down and come back. So sometimes what happens is when you change the flow from a higher level to a lower level, the cost map doesn't clear. So what you can do is there is a service called clear cost maps, which we can use to open the path for it. So suppose move out. Ask it to get back in the elevator again. You wait for it to get inside. It takes a while. The simulation is slow. So once it is in there, we'll just directly ask the elevator to go to floor 0. What I'll do is close the door and move downwards. Now, since we changed the map again, the floor again, we have to ask it to call the lobby map, which we'll do. It should load the new map. We'll ask the elevator to open the doors for us. So one thing you'll notice is that even though the doors are open, it isn't clearing correctly. So to mitigate that is what we'll do is we'll call this service clear cost maps. ROS service call clear cost maps. It will build the cost map again, local cost map again. So now we can ask the robot to move it. So we'll ask it to go to the pickup location. And ask it to go to the pickup location. As you can see, it will go back to where it came from and then just in the opposite direction. So suppose it was an open area, van or something can come up and pick it up and go. So I think I went a little fast. So if you have any questions about this or anything about ROS you want to chat about it, you can find me on LinkedIn or you can text me on, you can send me an email. Everything is fine.
Thank you very much, Amar. Impressive simulation, especially, and all the work there. I have some problems here listening myself. Is it everything okay? Amar, can you hear me?
Yes. Hello. Yeah,
Okay.
I can hear you.
Okay, perfect. No problem. Then impressive. I think that you have delivered a lot of value to the audience by showing this complex setup. And it's a setup that is already working. So you have shown how to make it work and the whole simulation, the elevator, the robot, the multi-mapping. Awesome work. Congratulations, Amar, really.
Thank you.
And then we have many questions here. Let me go with some that are not the most voted, but I think that people is worried about this. It's about the communication of the robot with the elevator. So how is this performed? I mean, in your simulation, you can do it because you can interact with the simulation, but in real life, how this would be?
So, so what, when I was building this specific project, I thought that, what we'll have to do is the elevators will need to have a specific API or something which the robot can communicate with. So I looked up several things, and I think there is a project called ROMI-H, which is being built for hospitals currently by Open Robotics. What they are trying to do is they are connecting the infrastructure to so that we can communicate it with ROS. So that is one thing which can be used to do this. So I know that the communicating directly to elevator in a simulation is easy, but doing it in a real life is pretty difficult. But this was an interesting challenge which I didn't really see anyone doing it. So I tried to do this.
Yeah.
So you should look up ROMI-H. It is an interesting project.
Okay. Yeah, of course. It's the point here was not the communication with the elevator, but the logic and the intelligence for handling how to move between floors and manage all the maps and path plans and all that. Right?
Okay.
Yeah. Then
so that we'll have to create a...
Sure, go ahead.
We have to create a specific algorithm that does it. Right now, it was that I gave it a specific coordinate that has to move to, like, it has to go to the wait for the elevator, wait inside the elevator. That's it. But what you can do is create a specific like a tree method. Like you can, I'll just I can't show it. Can I show it?
Sure. You can share your screen if you want.
So like this is how I actually use the coordinate locations. How I say the
we cannot see your screen. Can you share it?
I think it's shared.
Okay, here it is. Okay, now we can see.
Okay, so this is how I actually use the location that are saved, like it has a specific elevator, what is the where it is located.
Okay.
Then for the lobby, the drop and pickup area, then the rooms. So you can create this can be saved in a tree like format. Then you can traverse through it like it knows where to go. So you can build the logic out of this. This was just a simple demo to like you can do this here.
Okay. Okay. Perfect. Great. Then let me go now to the most voted question. That is one from Jane Kartunen. And he says, how could multi-mapping be implemented in environments without elevators? So, for example, in a parking hall where a robot can drive to a different floor using a ramp. How can we do that?
So for that we have there are different mapping methods available, like 3D mapping methods available. But what we can do is use the same like here we change when we know that.
So you would not use a multi-floor approach in that case?
Not exactly, no. Because in this, what the problem is that for the multi-floor, the problem is that the environment breaks. In maps with, what do you call it, connected areas in parking lots, we can have like from the first floor to the top of the ramp, we can have one map. Then we can ask it to change the map. So we can break the map at the intersection of the ramp and the entrance of the second floor. So we can use that. So we can provide a specific node that once the robot reaches here, we should load the next map. So in that way we can implement it.
Okay, yes. And the same approach would be useful, for example, for a single floor, but which is very, very, very large.
Yeah, right.
Right? Okay, great. And then another question here is how the robot knows in which floor it is. In case that, for example, the elevator brings you to a different floor because somebody else has clicked on this. So I understand that this is not the point of the multi-floor navigation, but people, they are interested in the practical application.
So what I was thinking about when I was doing this, that we should move towards infrastructure, like the whole building should have some IoT infrastructure so that it can directly communicate with the robots that are coming in. So like if we were to implement at a larger scale, we'll have 10 robots coming in daily. So we don't have to save the maps in everything at a single centralized unit. What we can do is, from a security standpoint, we can have the maps of that specific building and that building only. So when the robot comes at the lobby area, it can request the like IoT infrastructure of the building and can request the map from it. Then it can directly communicate with the elevator, so it knows which level it is currently on, which is it not on.
Okay, yes.
We need to have a proper infrastructure for it.
Yes, exactly. So once you have the proper infrastructure, the physical one, then you can apply the algorithms and all the code that you have developed in this simulation, in this environment. Right?
Yep, mostly.
Yeah, mostly. Yeah, great.
Because we will have to add more conditions and for making it more robust.
Exactly. Yeah, because the reality is different than the simulation, and then we need robustness on that. Very good point. Great. Then let me see. Okay, another interesting question here from the Shashank Bhushan, that he says, how do you manage the odometry representation in multi-floor environments?
So what is currently happening is the odom isn't being changed, like it is not being reset. So all the maps have a specific have been made in a specific origin. But what you can do is suppose I have the location, what do you call it? I know the location where the map changes. What I can do is, when I change the map, I can also ask the odometry to be changed, like the origin location of the robot to be changed, like where it currently is, localization.
Okay,
we can add that.
Okay, but makes perfect sense. Then, so there is another one about knowing about the elevators doors are open, and so in this case, are you using a door detector for opening,
No,
or
no,
you
no, no.
just knowing that it is because you are checking in the simulation?
Yes.
Okay. Yeah, it's a practical question again. So I
Yes.
remembered I was participating at the RoboCup at home competition, and then there we had to make the robot enter into the room once it has to, once the door was opened by somebody. So there we had to implement this detector of door opening and so on. In this case, it's not needed for the subject that you are presenting. That's correct.
I actually didn't have the time to build it.
Okay, yeah. But wait, Mom, let me tell you, the presentation that you have done, this work is awesome. It's awesome, really. It has a lot of value for all the ROS developers as the audience that they are there, because they can take this already working. And everything is working, and the elevator is working, and the robot can carry objects in the inside, and you can create the different maps and spawn. That's so much work that you have put there, and everything was working. So really, congratulations for that.
Thank you.
We can tell the audience that they can build this door detector, and then they can incorporate into the project.
Yes.
Maybe, yeah.
I have provided the GitHub repository too. Please add.
Okay. Then let me ask you one final question. Let me select here. Okay, so the pose of the robot. This is a question from Nitin Diman. And he says, how is the pose of the robot stored with reference to the floor level number?
Okay, so right now I don't have it. But what you can do is when the robot map changes, we can have a specific topic where it is being published. Like when the robot changes the map, we can directly publish it. Like currently it is on map flow 1 or flow 2. Then we can save it like that. But the thing here is we don't need to have maps for all the flows, because the structure of all the flows is going to be the same. So what we can do is, when creating the map, we only need to map out the different areas which are different in structure. So that covers the lobby and the floors which are unique. So once I have a single map for the floor, then I don't need to do it again for all the, suppose the building is of 50 floors. I don't want to do it for all the 50 floors, because I know the basic structure of the area is same. When I run it in there, if there are some differences, the obstacle, it will be covered in the local cost map. The global cost map is going to be the same.
Okay.
So that is not a problem.
Okay.
Exactly.
Okay. Makes sense. Okay, then I think that we have to leave here the questions for you. Thanks a lot, Amar, again for your impressive work, and see you around the universe. Thanks.